All right, we have three examples to do. First one is we want to find the surface area of a sphere with radius a. So if we're going to parameterize the sphere, remember that a sphere is rho sine phi cosine theta. X is rho sine phi sine theta, and z is rho cosine phi. So what it says is we want to parameterize, well, it doesn't say it, but we're going to parameterize this with the radius of a. Well, the radius is rho. So x is going to equal a sine phi cosine theta. Y is going to equal a sine phi sine theta. And z is going to equal a cosine phi. So what we've done is we've taken something that had rho, phi, and theta, and we have now reduced it to r of just phi and theta, because a is basically a constant here. All right, so let's go ahead and write this out. So we've got r of phi and theta, which is a sine phi cosine theta, a sine phi sine theta. Whoops, there should not be a... There we go. And then a cosine phi. We are going to need, according to what we did last time, to parameterize this correctly, to be able to find the surface area, we're going to need the partial. So we need the partial of r with respect to phi. So let's take the partial of each piece with respect to phi. Well, the first one, sine of phi, the derivative of that is cosine phi, so we're going to get a cosine phi cosine theta. For the second one, the derivative of sine phi is also cosine, so it's going to be a cosine phi sine phi. And then the last one, the derivative of cosine phi is going to be negative sine, so it's negative a sine phi. We're also going to need to parameterize with respect, I keep saying parameterize, we're also going to need to take the partial with respect to theta. So let's take the partial of r with respect to theta. Well, in the first one, we've got cosine of theta, so that's going to be a negative a sine phi sine theta. And the second one, we've got a sine theta, so that's going to be cosine theta, so a sine phi cosine theta. And in the last one, I don't have any thetas at all, so that's 0. That's actually going to be really nice here, because now we have to do the cross product. We've got to do r phi cross r theta. Now I'm going to kind of take shortcuts here when it comes to this, although writing this stuff out is not going to be short. I'm not going to write the I, J, and K on top, but just understand that I've written it in the order that I did with the R sub phi and R sub theta, specifically to make it easier to do the cross product. I'm not going to rewrite this in a determinant. So the cross product, eliminating what would be the I row and I column, is going to give us a cosine phi sine phi. Oops, that's times 0. So let's get rid of that. Minus, then it's going to be what? Minus a, it's minus negative actually, so it's minus negative a squared. So it's positive a squared sine squared phi cosine theta. So again, that was multiplying these two pieces together. First I did those two pieces, then I subtracted multiplying the second two pieces. I'm going to erase those little things in the middle there, but that's where that came from, just because I couldn't show it to you here. All right, now let's eliminate the j row and column. So if I eliminate that one, I'm going to have, again, 0, let's see, minus a squared, so it's going to be minus, but then we have to change the sign, so this is where it really gets tricky. This should end up being negative still. Negative a squared. Is that right? Is it negative? No. Yeah, no, that's going to be positive, isn't it? It's, yeah, wow. Really is kind of tough to keep all that straight. It's going to be positive. Positive a squared, yeah, double check that, but positive a squared sine squared phi sine theta, yeah, that's good. All right, and then eliminating the j row and column, this is going to be kind of long. That's going to be a squared, let's see, sine phi cosine phi cosine squared theta minus the negative, so it'll become plus. I think I'm going to have to jump down to the next line here. A squared sine phi cosine phi sine squared. Is that right? No, that doesn't seem right. The first one is a squared sine phi cosine squared theta. Yeah, that looks okay. The second one is minus the negative, so it's positive a squared sine phi cosine phi. It should be sine squared theta, which means that I made a mistake somewhere up here in my cross product or something somewhere. So let's see, where did I make the mistake? Hopefully you guys caught it already. Oh, I found it. This was supposed to be theta. Oops. Helps not to try and write with an eraser. Theta. There we go. That's it right there. Yeah. Go ahead, go back and double check that. But for some reason I changed my sine theta to a sine of phi there. Should not have done that. Okay, that makes sense. All right, so there's our cross. And by the way, this is probably one of the hardest parts about doing this problem, is just being careful on everything that you write down, because these things can get you if you make a little mistake somewhere. All right, what we should see is here I've got a squared sine phi cosine phi. Here I've got a squared sine phi cosine phi. I can factor that out, and when I do, what that leaves is cosine squared plus sine squared, which of course is 1. So really what we're going to get from this, well, yeah, I'm going to go ahead and write it out. May as well, just to make sure I'm not going to make any extra mistakes, is a squared sine squared phi cosine theta, a squared sine squared phi sine theta, and then a squared sine phi cosine phi. And again, if you factor those out, you'll be left with that cosine squared plus sine squared, which is 1. So that is our cross product. Now we have to take the magnitude of that. So let's cross those things and take the magnitude. So remember, the magnitude is each one of these things squared. This is going to get long, I think. All right, so if we square the first one, we'll have a to the 4th sine to the 4th phi cosine squared theta, plus, if we square the second one, we have a to the 4th sine to the 4th phi sine squared theta. If we square the last one, we'll have a to the 4th sine squared phi cosine squared phi. That's the magnitude. But we're going to want to simplify that because this thing is an absolute mess. Again, what you should see is between these two terms right here, I have an a to the 4th sine squared phi in both. If I factor those two things out of just those two terms, that leaves us with a cosine squared times cosine squared plus sine squared. So really what I get out of that is going to be a squared, sorry, not a squared. It's going to be a to the 4th sine to the 4th phi times 1. That's what you get out of both of those. So what that's going to give us now is the square root of a to the 4th sine to the 4th phi plus a to the 4th sine squared phi cosine squared phi. Yeah, that looks right. So now what I can do is I can take an a to the fourth out, and if I could take that out of both terms, and that's going to give me an a squared on the outside. I can take a sine squared phi out, and that's going to give me a sine phi on the outside. And what that leaves us with, if I take the sine squared out of this one, it's going to leave me with a sine squared phi. If I take the sine squared out of this one, it's just going to leave me with a cosine squared phi. But of course, that's 1. So really what we get here is a squared sine phi. And if that kind of looks familiar to you guys, it really should, because if you just replace a with rho, you have the conversion factor for spherical. So just replace the a squared with a rho, and that is the conversion factor for spherical. All right, all of that was just to be able to get the cross product. Now that the magnitude of the cross product. Now that I have that, we can actually find the surface area. This is why I said these are going to take a while to do. The surface area is the double integral over d of a squared sine phi dA. All right, but remember that our dA here is going to deal with just phi and theta. So let's go ahead, whoops, didn't mean to do that. Let's go ahead and, oh man, I'm running out of room big time. I wrote a lot bigger than I thought I was going to. I can still get this in here. So this is going to be the double integral. So let's see. Phi goes from 0 to pi, because it is a sphere. Theta goes from 0 to 2 pi of a squared sine phi d theta d phi. Fortunately, a in this case is a constant. We can take that out to the front. We can separate this because thetas and phi's are completely separable by multiplication here. So we're going to have 0 to pi of sine phi d phi times 0 to 2 pi of just d theta. So what we're going to get is a squared. The antiderivative of sine is negative cosine, evaluated from 0 to pi. And then the integral of from 0 to 2 pi of d theta, we've done enough times, we know is just 2 pi. So let's go ahead and finish this off. So what we have is we have a squared. Plugging in pi for cosine, we get negative 1, so that's 1. Minus, plugging in 0, we get minus 1. So what we get, and then times 2 pi. So what we get here is 2 times 2 pi times a squared, which is going to give us 4 pi a squared. And again, if you think about this, if you replace a with r, what you have is you have the equation for the surface area of a sphere. So we didn't really need to go through this entire thing to find the general surface area of a sphere. We know that that's 4 pi r squared, or we should know that that's 4 pi r squared. All right, I'm going to try and squeeze this in here right at the bottom. Looks like I'm going to go to the top of the next page. Hopefully you have enough room on yours. I am going to squeeze this onto the top of the next page then. For every sphere with radius a, the magnitude of r sub phi cross r sub theta is always going to be a squared sine phi. All right, that's just a good thing to note. I really don't like that star. Let's do a better star. There. For every sphere with radius of a, the cross product is going to be a squared sine phi. It will be the conversion factor.